So, today we're going to dive into a pretty radical new way to think about brain health. It's called the Brain Kinematics Model, and honestly, it promises something huge. Not just slapping new labels on things, but giving us an entirely new map of the mind itself. But okay, before we get to the map, let's talk about why we even need one. Have you ever just noticed how mental health diagnoses can feel, well, messy, right? Why could two people with totally different labels share the exact same symptoms? The lines get so blurry, and that confusion, it really points to a fundamental problem with the old maps we've been trying to use. I mean, take psychosis, for example. We tend to think of it as a specific illness, but it's not. It's really more of an outcome, a collection of symptoms like hallucinations or delusions, and it can pop up in schizophrenia, in bipolar disorder, or even in cases of severe depression. And that right there, that shows a massive crack in our traditional system. You can get to the exact same endpoint from completely different starting points. So what if we just stopped focusing on the labels for a second and started mapping the underlying dynamics instead? That is the absolute core idea behind the Brain Kinematics Model, or the BKM. The whole idea is to shift the question from what do you have to what is happening. Okay, so the model is built around this really powerful central metaphor, thinking of the brain as a dynamic landscape. It has three core parts, or axes, which we can think of as the terrain, the flow of water running across it, and finally, where that water settles down. So the first axis is the substrate. I want you to picture this as the physical terrain of the landscape. The deep riverbeds, the mountains, and the valleys inside the brain. This is its stable structure, its connectivity, and it's shaped by both our genetics and our life experiences. It basically determines which paths are even possible for brain activity to travel down. All right, next up we've got motion or flow. So if the substrate is the terrain, then motion is the water flowing across it. How fast is it moving? Is it like a calm, steady stream, or is it a turbulent, chaotic rush? This axis is all about capturing the real-time dynamics of what the brain is doing. And then finally, axis C is convergence. And this is all about where the water ends up. Does the flow settle into a calm lake, a stable, balanced state? Or does it get trapped in a whirlpool, just looping endlessly on itself? Or maybe it just floods and fails to settle anywhere coherent at all. Now this is where the BKM gets really, really elegant. It gives us a brand new way to think about that old nature versus nurture debate. Our nature, our internal vulnerability, that's the fixed shape of the terrain. But nurture, the environmental load we deal with, that's like the weather. And a heavy enough storm can flood even the most stable landscape. And this weather we're talking about, it's not just a metaphor. The model points to very specific environmental stressors, things like adversity in childhood, social isolation, really poor sleep, or substance use. Every single one of those acts like a heavy downpour, adding turbulence and pressure to the flow across our mental terrain. So with this new map in hand, how do the disorders we're all familiar with actually look? Well, the model lets us shift from thinking about them as these simple, flat labels to seeing them as specific locations on this dynamic map. Okay, check this out. Look at how this totally reframes two very different conditions, ADHD and OCD. According to this map, both can happen on a pretty stable terrain. The difference isn't the landscape, it's the flow. For an ADHD-type profile, the flow is rapid and unstable. It struggles to settle down. For an OCD-type profile, it's rigid and repetitive, getting stuck in those loops. Okay, so this is great as a metaphor, but to make it actually useful, the model turns these ideas into something we can measure. Each axis, substrate, motion, and convergence, gets a score, and basically a higher score just means there's more difficulty in that specific area. This is how we go from a powerful idea to a functional quantifiable tool. And here it is. This is the map we've been building up to. By plotting those three scores in a 3D space, we can actually see where different conditions tend to cluster. Each of these colored regions you're looking at represents the typical cloud for a different disorder profile. It's a completely new way of visualizing the entire landscape of mental health. Now, this is absolutely crucial to understand. These are not rigid little boxes. They are dynamic clouds. And that visual language is so important because it captures the reality that our mental state is always in flux. It changes with stress or a bad night's sleep, and it evolves through the different stages of a condition, from onset all the way to recovery. And all of this brings us to the really fundamental shift in thinking that the Brain Kinematics Model offers. It's a move away from static labels and towards something way more dynamic and, frankly, hopeful, tracking journeys. The source material puts it just beautifully. We can now trap trajectories as paths through the 3D space. I mean, just think about what that means for a second. We can actually map a person's movement through this landscape over time, charting the course of an episode from its beginning to its peak, and hopefully toward recovery. And this really is the ultimate takeaway. A diagnosis is no longer a fixed, lifelong identity. It's simply a current location on a map. And because it's a map, we can track movement. We can actually chart a course, a dynamic journey toward a more balanced state. So I'll leave you with this question to just kind of chew on. What changes if we start to map mental health not as some fixed destination you arrive at, but as a continuous journey through a dynamic and ever-changing landscape?